Bismillah. Good morning, grade 8. I hope that you will enjoy, inshallah, with our chemistry session today. Now, inshallah, we are going to complete the previous sessions that we studied before about the digital signal. And what about the difference between each signal, each analog signal and digital signal? It's okay. Let's complete. Yahya, can you read this paragraph, please?
Yes. What
Okay.
is a digital signal? Digital signals, the digital thermometer displays values. Examine the digital clock in the image to the right.
Yeah, this image.
The,
He means this image that you see at the right. Okay.
the time is 9:27. The clock only changes when the time is 9:28.
Really?
This is
Sure. Yes. Complete.
This is the create information about the time of day. Your digital thermometer gives the create values for the temperature until the next value. Digital information is not continuous.
It's okay. Thanks. Yeah. So about digital signal. Okay, Mu'taz, can you read Mu'taz digital signal?
Yes, a digital signal is an electric signal whose value changes between two values. A digital signal is not continuously changing values like analog signals. The information being communicated is inverted to numbers or digits to be displayed, transmitted through waves, pulses, or stored. Information such as computer data and telephone calls can be encoded into electrical signals.
So it can be encoded into electrical signal, okay? And this code can't allow to anyone to enter this encode except the calling only. Understand?
Conning? What is conning?
Calling person.
I thought you were
Yes,
saying
okay,
calling.
understand?
Yes.
It's okay, complete matters.
Signal to or from a computer is encoded into binary numbers, such as the two values on, one, and off.
0, 1, and of 0. So two numbers, okay, such as the two value on 1 and of 0. Okay, okay, thanks. After that, this is the about 3D thinking about digital signal. This is shape of digital signal from 0 to 1, then still for a while, then reaches to fall down to 0 again, still for a while, then move up to 1, still, okay, move down, and so on. Okay, so examine. So is this
Three-dimensional thinking writing connection.
examine digital signal in the figure to right. How does the data in the model represents on or off value that are found in digital signal? Okay, 0, it will be off. 1, it will be signal. Okay, on.
It will
Then
be on,
fall down to be
off,
off. Then 1 to be
on.
and so on. Okay. The computer domino effect. Okay, let's investigate about the computer domino effect. How does digital signal encode information? Can you read, Muhammad, please?
Yes, digital signals are composed of only
قاعد
two
ألعب
possible.
ما قاعد ألعب.
You were only given two possible values. How could you encode information in a signal? Let's investigate.
Let's investigate. Okay. How does digital signal encode information? Okay, Yahya, can you read please first paragraph, Yahya?
Yes. Binary information such as computer data and telephone calls can be encoded into electrical signals. A signal to or from a computer is encoded into binary numbers. Recall that a computer can translate information that represented by ones and zeros, which represent on off. In the investigation, the computer domino effect, the domino computer is designed to take any combinations of ones and zeros and do simple addition. If the domino computer has more inputs and outputs, it could calculate larger numbers.
Okay, good. So it's called binary information that the computer need, okay, to make encoded for this digital signal, okay, to be work. As information such as computer data and telephone calls can be encoded into electrical signal, okay, coded into electrical signal codes, okay, signal to form a computer encoded into binary number. Recall that computer can translate information that is represented by 1 second and 0 second, okay, which represent on off. Okay, so it will be from 0 second to 1 second, it will be off from 0 and on from 1, okay, to make encoded for the new order, okay, that it was taken. Okay, in the investigation, the computer domino effect, the domino computer is designed to take any combination of 1 second and 0 second and do simple addition. In the domino computer had more inputs and outputs, it could calculate large number. Okay, Mu'taz, read the second paragraph.
This is how a real computer works. Instead of dominoes, the electric signal is either on or off. Computers can do much more than add numbers. They can show images, play music, format documents, and send digital signals to other computers. The more inputs and outputs technology like a computer has, the more information it can hold, and the more complex the calculations it can perform.
Yes, so this is how real computer works. Instead of domino, the electrical signal is either on or off. Computer can do much more than add number. They can show image, play music, format documents, and send digital signal to other computers. The more inputs and output technology like a computer has, the more information it can hold and the more complex the calculation it can be formed. All this by encoded digital signal. Understand? So think about a photo taken with digital camera. A digital photo holds on color value at one particular location called a pixel. This is called pixel in the unit of camera. As more colored value are added, the information becomes clear as this. Okay, so this, okay, this, and so on. Understand me?
Yes.
So it's by what? It's by digital.
Yes.
It's by what? It's by digital. Okay, so when you increase the pixel of camera, when you increase the pixel of camera, okay, you will take a clear image as this. This is the first one, okay? This is the first one, okay? Have no large number of pixel in camera. By increasing this pixel, it will be clear for a while. More clearly, and this large clearly, and this is more intensity, okay, clearly. Okay, so this is by adding what? By adding pixels.
Pixels.
Okay, can you read, Muhammad, this paragraph?
Think about a photo taken with a digital camera. A digital photo holds one color value at one particular location, called a pixel. As more color values are added, the information becomes clearer.
Clearer. It's okay. So this is the credit. Okay, can you read, Yahya, the first paragraph?
Yes, yes. In the first image, the digital information exists, but it is not enough to make out what the image actually looks like. As more information is added, the photo becomes clearer.
Yes, okay. Thanks, Mu'taz. Mu'taz, can you read this paragraph, second paragraph, please?
Yes. For digital sensors and probes, information is continually reaching the sensor. Think about a digital camera. Light is continuously reaching the camera, but each pixel can hold only one value or color. The camera records each pixel in a process called sampling. For most digital cameras, the camera takes a sample of each pixel 1 times 7 powers. 1
Yeah,
times 10 power 7.
1 times 10 power 7 times per second. Okay, understand this to be more clearly.
Yes, yes.
Okay, complete Mu'taz.
This is why a video from a digital camera looks continuous. Sampling is used in all digital probes. If you had a digital thermometer and the lab information stairs that had a high sampling rate, the data would look similar to the analog information.
Yeah, it's okay. So this is about how can we increase the image to be more clearly by increasing the pixel of camera. Okay. Excuse me, guys.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
عليكم السلام
عليكم
ورحمة
السلام.
الله.
هلا بالغالي، مين؟
محمد العقيل.
محمد. Where are you,
إيه.
محمد؟ كيفك؟
الحمد لله طيب.
الحمد لله. Good morning طيب.
Good morning.
Or good afternoon.
Yes. عادتنا.
رمضان كريم.
Yeah, good afternoon. Okay, guys, let's complete.
Let's complete.
Okay. Muhammad Agil, can you read, please?
How does the way digital signals transmit information support your claim about why cassettes are no longer used? Record or evidence be in the chart at the beginning of the lesson.
It's okay. This is about what? Listen, please.
What happens to a digital signal over time? Digital signals are sent in discrete units. Each unit of information consists only of either a 1 or a 0. What would happen to the information over time?
What would happen? Okay, this is number 1. Yahya, can you read, please?
Trace back below is a color pattern made with 2 colors.
Yes.
In your science notebook, trace the image on the worksheet provided by your teacher as precisely as possible with color pencil. Try to ensure all the information about the image is contained.
It's okay. Mu'taz, second paragraph.
Once you have completed your trace of the image, trade science notebooks with a partner. Take a piece of paper and trace your partner's copy of the image. Again, try to ensure all the information about his or her image is contained.
It's okay. Thanks, Mu'taz. This is compared between what and what?
Could not find the text to read.
Compare your trace of your patterns image to the original. What do you notice about the quality of your trace? Okay, what about? Who can answer me? What about the quality?
It's gonna be not. It's not the different. It's not the
Yes.
same.
Not the same, and not clearly. Okay, not clearly. Okay. So let's read about what happens to a digital signal over time. It's about digital signal. Okay. Who can read? Muhammad? Muhammad Jibreen.
Yes.
Can you read, please?
Digital noise. Just like analog signals, when digital signals are sent, noise is added to the original signal. Examine the figure to the right. When noise is added to a digital signal, the information can still be clear to the receiver. In the investigation, trace back. You likely had a few areas that were not an exact trace of the original image. If you received this trace, but knew that red and blue were the only colors coming from the original, it would be easy to interpret what the original image looked like.
Yeah. So the original image to know, okay, that the original image look like, okay, so it will be from the main basic colors that we can see. The previous example, red and blue colors. It's okay. If you received this trace but knew that red and blue were the only colors coming from the original, it would be easy to interpret what the original image looked like. Okay, as red and blue also only. Okay, so it's digital signal, but in a quiet place, and this is the This is the digital signal of noise place, and the two beside each other will be formed by this shape. This is recorded signal by noisy place. Okay, Muhammad, again, can you complete, please?
Okay. I read this paragraph.
Yeah,
Or
this
continue.
paragraph from a device.
A device that receives and translates a digital signal is only expecting one of the two values, on or off. Noise then is easily filtered off without significant deterioration to the original information, even when transmitted over long distances. Higher quality information can be received when the original information is not altered by the noise added to the signal. This makes digitalized signals more reliable way to encode and transmit information than analog signals.
It's okay, thanks, Muhammad. So this device that receives and translates digital signal is only expecting one of two value, not the two, one of the two value, on or off. On or off. Noise then is easily filtered off without sufficient, okay, deterioration to the original, okay. Information even when transmitted over long distance. Higher quality information can be received when the original information is not alerted by the noise added to the signal. This makes digitized signals a more reliable way to encode and transmit information than analog signal. Okay, and this CD and DVD. Okay, CD and DVD about the digital signals and how can it transfer the signals. Okay, guys, I think that the session will be ended now. 1 minute only is remained. Thanks for your participation, all of Yahya, Muhammad Jibreen, Mu'taz, and Muhammad Agil. Okay, happy Ramadan, guys, and I hope that you enjoyed from our session. Okay, and I
Yes.
hope that you will everyone
But Mr.
will inshallah participate in the next session inshallah. Yes, Muhammad.
in Ramadan, every class is only 30 minutes.
Yeah, in Ramadan only 30 minutes. Begin from 2. First session begin with 2 to 2:30. Then the second session from 2:35 to
Yes, I know, Mr. I know the
3:05.
schedule.
Yeah,
Yes.
as
So
I say,
that's only
same
gonna be
schedule,
for 1 week.
same schedule. Okay, as you studied before.
But
Okay,
for only 1 week.
not only 1 week,
weeks.
for
2 weeks.
14:05. Okay, our schedule will be continue to 14:05. It's okay.
No, next month.
Not next month, this month.
Ah,
Okay,
okay.
this month, for 14:05. 14:05. Okay, today we are in 26:4. Okay.
Uh-huh.
Okay, guys, I'm pleased to explain these sessions with you. Okay, thanks for your participation and
you.
good luck, guys. Thanks, good luck.